Hi, everyone. Thanks for joining us for our Full Steam Ahead webcast. I'm excited today. We've got Rob Klenner from Baker Hughes joining us. Rob is the Director of Geothermal Technologies and Innovation and has over 12 years of experience in subsurface technology development for geothermal, oil and gas, and CCUS. Currently, he leads Baker Hughes Geothermal Solutions Partnership with Greenfire Energy and is the Executive Director of the Wells to Watts Geothermal Consortium, which is what he's here to talk about today. So without any further ado, I will pass it off to Rob.
Hey, thanks, Brian, and thanks Geothermal Rising for giving me this opportunity to talk about Wells to Watts and our exciting partnerships and what we're doing in our geothermal consortium. As Brian mentioned, I'm the executive director for Wells to Watts, and it's just a great time where we've hit some key milestones on our well testing that we're currently doing in Oklahoma City, and I want to talk about that, but also what our consortium is doing in other projects that we plan to do in the future. So Wells to Watts, what it is and maybe what some perceptions are around Wells to Watts, but it's a way for us to get oil and gas industry engaged. And this was an idea that I had about 2 years ago when I was getting re-engaged into the geothermal community. And I thought we really needed some involvement from the oil and gas industry. So uniquely, I'm located in Oklahoma City, where I get the pleasure to be with some of the large independents like Continental Resources and Chesapeake Energy, who were critical in developing our shale resources and the technology and innovation that they drove to unlock those resources, predominantly around horizontal drilling and hydraulic fracturing. And so it gave me a great opportunity with my network base here to say, hey, we have these testing capabilities within our own facility in Baker Hughes and what we do at our facility in Oklahoma City, but our other facilities around the globe too. And really create a true partnership to get the oil and gas industry engaged as there's interest for them to understand how can we use our assets or even how can we use our skill sets to develop out this vast amount of resource. Even from a personal note, I'm a geologist by background, and one of the key opportunities for me when I saw geothermal energy was just the vast resource. So I kind of had a divergent path where I saw the upstart of the Bakken and North Dakota and the vast energy resource that was there, but also saw the resource potential that was in geothermal, and did a lot of my master's work in geothermal. And saw the true resource that could be developed through enhanced geothermal resources and what that really can do for the geothermal community and bring renewables online. So with this technology and the involvement of the oil and gas industry, one of the key technologies that we're first exploring is actually the use of advanced closed loop geothermal systems. And we're working with our partners, not just with our executive partners, Chesapeake Energy, Continental Resources, California Resource Corporation and Impacts, but also technology supporters who are part of this consortium, which include Valorec, Greenfire Energy, and then we also have waste heat technology providers, advanced thermal voltaic systems, and nice thermal harvesting. So although our first projects are looking at closed loop geothermal, we're actually broader than that. Our other projects now, as we're evolving with past year one here, is closed loop on the first project, waste heat technologies on our consecutive projects, but also look at how can we look at technologies, enhanced geothermal resources, and even high pressure, high temperature technologies to test. But it's really an adaptive way for us to move within our own R&D capabilities, our joint resources, and how can we quickly apply these in the field where we know we could take these technologies forward and test them in a relatively short timeline. So December 8th was really our press release around this consortium, and pictured in the picture here is our test well and our current members. So everyone knows that geothermal is available, but it's available with the right technology. And one thing that I really start to think about is coming from not only my geothermal, CCUS, but also oil and gas experiences, that there's different ways to use technology and develop out these resources. So we know there's a lot of conventional resource today and what we've developed, but as we start to think about what we can grow and how we use unconventional technologies, we have a lot of resource and we know we can untap it with these new technologies. And really that's kind of the goal of our consortium, is understanding these new technologies and how to apply them in the right conditions, but also in the right applications when we think about the surface and the use that we have there. So everyone knows, probably on this call, and understanding the difference between enhanced geothermal systems and advanced geothermal systems, and the type of technologies to deploy these, whether it's more on a hot dry rock scenario, or the technology to use horizontal drilling, hydraulic fracturing, and what we can do in enhanced geothermal systems. And it seems sometimes that we think one of these technologies is the solution or the silver bullet. But if you think about oil and gas industry, it really depends on the resource in the reservoir. And that's kind of the approach we're taking here is, how do we apply these technologies in the right resource? Much like you would think about steam-assisted gravity drainage, CO2 EOR, shale resources, more conventional production. Many of these technologies access the reservoir differently. So it's a good opportunity for us as a consortium to look at these technologies, but also innovate on top of them, because we know this is most of these are generation 1 type technologies, and there's a lot of innovation along the way once we can get them out into the field. So it'll provide us an iterative process to test these technologies, but also go back into our research and development lab, understand how we can do better, how do we bring the efficiency up, but also the cost down. So the first technology is we're partnering with Greenfire, who has a green loop technology, which is a downhole heat exchanger, a tube-in-tube design where you have an annular space and then a centralized vacuum insulated tubing, where a working fluid, whether it's water or other working or compatible ORC fluids, is pumped down the annular space, picks up heat along the well, and then is produced back up insulated tubing. This is where we're partnering with Valorec New Energies to apply their technology in our test well. What is unique too with this technology is also the opportunity to contact the reservoir fluid, whether that's a liquid or steam dominated phase of the reservoir fluid. And although a lot of people say, it's a pure conduction type system, in most reservoirs, you actually have reservoir fluid moving in and about the system. So there is hydrodynamics in the system, right? So as you start to think about the hydrodynamic flow or contact of the fluid flow in the reservoir and allowing that to exchange heat with this downhole heat exchange system, it's not purely conductive. It's also has some convection that's occurring in and around the wellbore. So that's a very important variable for us to understand and model, and how we implement this technology in the right existing wellbore settings, and not only in geothermal reservoirs, but also consideration into existing oil and gas wells that have been drilled today. One of the key case studies where Greenfire is deploying this is at the geysers with their California Energy Commission funded project. It's a great project to see how to revitalize the geysers, where you have makeup water that's pumped up to the geysers and re-injected to enhance the production and the reservoir pressure here that is depleted over time. And so I kind of see this technology as almost from my background on enhanced oil recovery, almost a water flooding or enhanced type scenario where we can implement a new technology in the downhole and instrument this out to get some of the heat back up to the surface, and back to a capacity that once was at an existing geothermal reservoir. But one of the opportunities is, how do we use not only existing geothermal fields and the wells that we have in existence there, but also oil and gas wells. And this is important too, because as we transition into new energies, not only thinking about it as oil and gas well anymore, but is it an energy well? So how do we redesign oil and gas wells in the future so that not just produces oil and gas today, but it also produces geothermal energy in the future? So there's many wells around the world, and at this point, we're looking at retrofitting some of these, or just even a fraction of these, could bring a large market and actually geothermal forward by using technologies like this. So one of the key examples was to utilize our Energy Innovation Center in Oklahoma, where we actually have a test well, where we drilled the test well and built an office around it. And we were able to now go in and instrument out an advanced closed loop system using the green loop technology of GreenFire and test different scenarios in reservoir conditions. And then how do we apply and scale this at different locations worldwide. So the Energy Innovation Center located in Oklahoma City is a 10,000 square foot indoor and outdoor lab. So as part of this building has evolved over time from not only the different technologies we've looked at, but also the digital transformation. So blending digital into the new energies and the low carbon mix and the technologies that we have at Baker Hughes. But it really is an opportunity for us to test things very quickly and get them out into the field and test them and launch new products. Currently, there's close to 50 research engineers and scientists that work here. And it's a building that works across the full spectrum of Baker Hughes. So we have subsurface capabilities and expertise all the way to the surface side, and then the digital ecosystem that branches around that. We're also uniquely co-located with Oklahoma State University after our donation of this building to Oklahoma State a couple of years ago. So we still maintain our offices, we still maintain the lab, but it gives a unique blend as we continue to understand how to work together in a commercial and academic setting. So some key figures for the EIC. Here's a picture of the high bay. So this is kind of on the back end of that previous screen that I had shown in the previous slide. And on the bottom left there is the wellhead, but it's a very flexible lab, and the way that it was designed was we can work on many different technologies across Baker Hughes. So we have many inventions that we submit and file across the spectrum from the different expertise. But it's also a key place for us to branch across different technologies and understand how they work together. And the unique setting that we have from the setup here is not only just a well and a test facility from the subsurface side, but we also have an organic Rankine cycle system sitting out behind the wall here with our partner Ice Thermal Harvesting. So we have 2 test wells within the facility. One is drilled to 65 feet. The other one is 400 feet deep. And we're able to transform this well now into a geothermal flow loop. We also have some visible flow loops. We have core scanning, flood and preparation space for reservoir characterization. And we have plenty of power and chilled water to run the different tests that we have planned within the facility. As far as different technology reviews and DOE and government funding within the past year, we have several projects underway, but we're really key onto external engagements and collaboration, and that really is a thrust in the partnership of Wells to Watts itself. So like I mentioned, December 8th, we launched this consortium. We continue to solicit new members, whether it's new operating partners on the executive membership, but also new technology partners. So open to new technologies for anyone interested in listening in today to test it and work with the partners and how we can apply the technologies in the field. So as far as timeline, when we talk about our closed loop project, we have been pretty aggressive as far as retrofitting the well and the capabilities. And one of the key things, and maybe just to even talk about on the partnership side, is partnership is really key here. We knew as a company at Baker Hughes, we could do a lot of this testing ourselves, but we knew we would be right at the start again when we go and talk to different oil and gas companies or other geothermal operators on how this technology can be advanced. So it really gives us a great understanding to go and actually test this and learn alongside each other. but also learn alongside with the technology companies and what can be done better, and how do we join forces and our resources to really learn and go through some critical questions, understand the risks, but also understand the performance and how to bring this out into the field. Especially for first-time projects, that is very critical. The other key component is adding the waste heat technology on top of this. So now we have a full data set from the subsurface to the surface, and we have the ability to understand the full package. And almost at times it's one of those, and I've had many questions on this, is, you know, we can model these systems, we can understand, but that's also a key component to this, is not only just modeling that, but doing a design of experiments around the green loop system and understanding what its capabilities are and how we can generate power with the ORC system. So as we get that information, we can actually improve our models and also understand how this scales out to the field. So over this first year, we've been identifying well candidates, looking at different applications, not only just on the power generation side, but we've also had some interest for different techno-economic studies around direct use applications. And we've also had other engagements, not just from the consortium members itself, but other off-takers, companies that are looking for geothermal and how we can use this technology and use the consortium expertise to actually go do a project for them in the field once we have our learnings here from the test well. Once we have the test data set and we generate this over the next few months, we'll have a full test capabilities, test data set. We'll be able to simulate this, but ultimately, how do we move quickly into the field and do something within the next year where we can strategically align not only with the operating company and the well owner, but also on the power generation and the offtake side. And then as we start to learn and do these in the field, it's all about cost out, scale up, solving some of those operational challenges, and understanding where we can lean out on the process side to make this a commercial product and scale very quickly. So the goal of the test well upgrades for wells to watts is retrofitting our existing 400-foot well. Here you can see it says 300 foot. But what we did was we took 10 30-foot sections and installed that in the well. So we have a working depth of 300 feet. We're able to demonstrate different commercial technologies, not just from the green loop, but also the insulated tubing and the waste heat technology, the two interchangeable waste heat technologies we plan to look at. But we also are going to be gathering a lot of data. So discussing how we can use this information, this data, to look at digital twin type ecosystems and understand the performance of it overall and how to optimize. So the test well, as I mentioned, is 300 feet deep. We have a 20-inch casing. The 20-inch casing is what it was original, fully cemented and plugged on the 20-inch casing. And apologize, I think this is a duplicate graphic down here, but this is the 20-inch casing. This is fully cased off to the subsurface. So of course, at 400 feet deep in Oklahoma, for you that know geothermal resources, this is not a prime geothermal resource area. So the temperature is actually fairly cool. And so we have a fully, from an environmental standpoint, fully cased off to any local aquifers that are here. What we did then was we pulled a vacuum between this annular space. So once we are operating the heaters and fluctuating the temperature of the well itself, we're not radiating any heat out into the subsurface, so we can maintain a fairly constant heating element in and along that 9 5/8 inch casing. So this is a 9 5/8 inch casing. And then within that this is where we have the heaters in and along the 9 5/8 inch casing. We will have water that fills this space here, and then we'll have that 7-inch and a 4.5-inch inner diameter vacuum insulated tubing. So this will make up what we call the downhole heat exchanger in the green loop of Greenfire's technology. And we're really simulating kind of that last 300 feet of a closed loop system of an actual wellbore. So prior to installation, this is what we had done with the 9 5/8" casing, is we put in these heat transfer grout along with many stainless steel tube heaters, almost about every meter along one of the 30-foot joints. So we have quite a few heaters in and along the joints here. And then we have several different control zones where we can control the heaters at different temperatures for which we want to mimic the downhole conditions. So we could have degraded heat, so we can mimic any cool-off effects that we might have within the reservoir running the system, or we can control the zones independently if we want to have different temperature controls in and along the 300-foot heated section. So of course, in order to do that, we have enough power that we can send downhole up to 750 kilowatts to artificially heat this up. And then it'll be about the efficiency of understanding how much heat we're getting back out of the system and power generation we can have from the ORC. This was prior to installation. So as you can see, there's a lot of cable in and along each casing string here. This cable is what we typically use for our electrical submersible pumps, so industry grade cable. In installing each of those joints, connecting up the cable, and then working with the crew to install those, which took close to 2 to 3 days to install these, and working within that 9 5/8 and the different casing arrangement we had. The wiring was one of the more challenging, and a lot of learning going on the way to tie this all together. Here's some more pictures of the wiring and getting it up and through the wellhead. Took quite a bit of time to understand how to do that, and then doing the different tests along the way to make sure everything was working in proper order as we continue to install it into the test well itself. So we will be running several different designs of experiments. The temperature that we'll be able to work up to is 450 degrees Fahrenheit. So what I tell people is we'll be able to test different reservoir conditions. This will give us, we could test a 200 degree Fahrenheit reservoir if that's in North Dakota, all the way to a 400 degree Fahrenheit reservoir in the Haynesville of northern Louisiana, or anything in between, between the Permian or LA Basin. We can mimic those different downhole temperature conditions. And then we can process up to 200 gallons per minute. For these initial tests, we'll be using water, but that doesn't limit us for doing other working fluids, especially ORC compatible fluids, since this is a closed loop system. We can run that through the ORC. So it provides some modular capabilities for us to look at these different refrigerants or hydrocarbon-based fluids, and how that integrates into the surface facility as well. This is the near installed picture. So as of this past month, we initially installed all the major equipment, and we're currently doing some downhole heating tests, and we'll start up the flow loop here shortly. So we'll have the ability with our horizontal Baker Hughes horizontal pump here, H pump, will act as the circulator. We have a heat exchanger as well here when we're not circulating fluid within the ORC that sits right outside this well. We have some expansion tanks and all the other equipment for when it comes to temperature sensing. So we'll be able to monitor temperature in and around at the several different pieces of the equipment here, but also temperature measurements throughout the wellbore too. And we'll have all that information to understand the performance. We can control the input temperature and flow. And so we'll have several different power curves that we can create once we simulate these different reservoir conditions. And we can always replicate reservoir conditions from time to time on any other basin that our customers have interest in. Project 2 will be working with our waste heat recovery. So not only this organic Rankine cycle system provided by Isothermal Harvesting, who's a technology affiliate into the consortium, but we'll be looking at the full integrated package here from subsurface to surface. And this is very valuable working with doing these demonstration tests. Is designing and understanding the full package, not only just in a lab-based setting. And this is why, on a very scaled up setting like this, we can have a good understanding of how we can properly install and put this into the field. So again, very, very common questions I have is, a lot of this equipment is provided. You can do some scaled down tests, but having a near demonstrated project gives us the ability to design and go do this in an active well, and the many different candidates that we're looking at this year. So for 2024, a lot of the things that we're doing now is just understanding, where can we actually go do this? Not only just within the United States, but also across the world where we have existing wells. We have many companies, as I mentioned, coming to us today that some of them don't really understand what geothermal can do for them. They understand that geothermal is a solution, but they just don't understand how to go do it properly. So it gives them an opportunity to engage with us at the consortium and some of the things that we're learning and how we may be able to apply this technology. It's a great time for geothermal in general to talk to a lot of these customers. I have customers that are learning, from us on hydrogen or direct air capture, as many of you know that wind and solar can't meet all of their needs, especially because it's not base load. But the conversation can quickly turn when we talk about the heat supply that we can provide in a lot of these situations. So even though some of the testing that we have around the ORC and the closed loop system itself, some of it could actually be for direct use applications and industrial purposes. So there's many different wells, many different opportunities when we start to think about oil and gas basins and where there's overlap between not just geothermal resources, but offtake needs. But also we'll be able to refine analyses at these locations as we get data out of the system itself and have a better understanding of what we can do moving forward with this type of technology. So in summary, I welcome anyone out there that's listening today for new technology partnerships and any future projects or opportunities that you may have to not only use the expertise out of the consortium or the technology we're developing, but we're also looking at new technologies, new areas, new projects that we could evaluate or develop new technology along the way to bring geothermal forward. And it doesn't necessarily have to be a subsurface or a surface-based technology, but even the evaluation of new tools or digital tools, evaluation capabilities of resources, and that can even be monitoring-based technologies. The whole goal of our consortium is to bring an industry that's traditionally been oil and gas into the geothermal side, help them understand it and learn, but by creating this ecosystem, how these different technologies come together and help develop out assets for them where they see particular use. Enhanced geothermal systems is, of course, very interesting. Like I mentioned early in the conversation and the presentation, a lot of these companies are traditionally independents when it comes to what they've done from a shale development standpoint with horizontal drilling and hydraulic fracturing. And so there's many different technologies today to enhance the reservoir, especially mechanically, and induce fractures within the reservoir. So a lot of expertise is there, and a lot of existing wells that have been hydraulically fractured. So how can we use them and apply some of these different technologies to repurpose existing oil and gas infrastructure? And then waste heat technology. There's a lot of novel opportunities there, whether that's even on packaging, or even on the different use of working fluids, or how we pair subsurface to surface, but also any heat exchanger technologies, or novel techniques around direct air capture or hydrogen, and how we pair everything together. And then also high temperature, high pressure solutions. So traditionally Baker Hughes, what we do on the drilling, completions, and even on the production side, how do we start to push technologies into the future to handle harsher environments, more difficult scenarios when we think about different rock conditions that traditional oil and gas technology hasn't held up against. And we make it more affordable when we start to talk about well construction and the surface facilities itself. So as we continue to move into the field, even on with this closed loop technology or other technologies, we understand that there's going to be advancements and innovations around the high temperature, high pressure solutions too. So in general, very excited for what Wells to Watts has accomplished to date with our technology on the closed loop side, and the commissioning of our site in Oklahoma City. But very excited where it's also going, not only with the pilots we intend to do in the future, but also the other technology advancements that we look to test and understand in this space too. So with that, I thank you for listening, and open for any questions.
Thanks, Rob. Great presentation. Exciting stuff happening there. We are going to open it up to Q&A now. If anyone has any questions, please enter them via the Q&A function in Zoom. We've got one in there already that I'll get to in just a moment. In the meantime, I've got a couple of questions for Rob myself. Rob, you talked about other people getting involved. If someone else wanted to get involved, how would they go about joining the consortium?
Yeah. As executive director, I'm kind of the first line of defense, and whether you're an operating, we kind of have the two tiers here. There's the operating members, more traditional developers, whether you're an oil and gas developer or even a traditional developer, and would work with the existing members to see if you're a good fit to bring into the consortium, also the knowledge and the brain power. And so it's a kind of a committee-based approach where we work with new executive members. But then from a technology side, we're always open to understanding new technologies that are out there, especially technologies that are looking to be applied. So these are things that are probably more on the technology readiness level of a 4, 5, 6, or even 7. Things that we want to test quickly and get out to the field within a year or two. So whether you fall within either of those buckets, I'm happy to have a conversation and understand how to get you integrated into the consortium.
Great. And you mentioned other technologies. Are there any other than you talked about the closed loop and the waste heat, but are there any other specific technologies that you can share with us that you're working on?
Yeah, I think we're open to evaluating the other technology spaces, right? So, for us, it was key to find, like any consortium, it's not we all sit down in one room and say, hey, let's go do this. It took months, to agree on how we come together as a partnership and a group with multiple parties. And that took everything from the operating members to the technology members. But closed loop just kind of gravitated one because we have the flow loop and what we were doing there. But that doesn't mean we can use the flow loop for just closed loop or, the green loop technology by Greenfire. We can test other things when it comes to wireline systems or sensors downhole. Really, it gives us an environment to break or accelerate things, right? So, we can put things in this well, we can test it. I like to say we can try to break it, right? I think that's what we want to do, is accelerated testing within a low-cost environment before we get out to the field. So looking at high pressure, high temperature opportunities. But then I think the interest is there on enhanced geothermal systems, right? So as we continue in the consortium, it's developing separate tracks around these technologies, development-wise, but also more wellbore construction or typical oil and gas technology we would want to move into geothermal. So we're looking at multiple pathways, and as a consensus as a group, we serve as a steering committee where we want to go and develop different things, and everyone's voice is heard on where we want to go.
Sounds great. Let's see what questions we have. Okay, we have don't have a name with this one, but someone has anonymously asked, for the test well capacity of 750 kilowatts, what kind of productivity index are you expecting to see?
Yeah, that's a good question. I mean, and that's kind of the reason for the test itself, right? So the 750 kilowatts is kind of the max threshold of power that we would put down hole to artificially create the heat, basically heat up these heating elements, resistive heating elements. So, it's obvious we're not going to get 100% all of that, energy we put down hole back up to the surface. And so that's kind of the reason we're doing the design of experiments. We can control the temperature inlet. And then we understand what energy we have down hole. And then we'll be able to measure flow rate and temperature out as well. So I would say stay tuned, because that's where we're going in understanding this. And we gave a paper on publication this past year at GRC, so feel free to download that and read it. But follow on conversation, we want to be able to see the performance of that and actually what we get out as a productivity side. So I won't share any details, as we'll understand that in the future.
Sounds good. And Ty Sabia asks, there are several Western states included in your plans. With Western states come public lands and federal mineral estate. How do you plan to account for the time it will take to engineer permits for projects that involve public lands and federal minerals? This includes proposed activities for both commercial power production and direct use. Where does permitting fit into your timeline?
Yeah, that's a good question. We I would say are evaluating where these locations are. And I think key locations would be where we are already working with an operator that has the rights to an existing well, and knows the permitting process within that location. So permitting wise, obviously that's going to be state by state, like you mentioned. Baker Hughes, we're not an operator, so we don't do the permitting. We work with our operating partners. So we'll work with our partners that I mentioned that are a part of this consortium, especially if it's part of their asset already. They probably have a fairly streamlined process to do that. And if it's an existing well, we're not producing any minerals out of it using this process. Hopefully it's a bit straightforward on the permitting side.
Great. And we have another anonymous question here. Rob, would you be interested in partners from academia from outside Oklahoma, especially on the modeling side?
Yeah, we're like I mentioned, we're definitely open. So currently we only have our executive members on the operating side, and then we have the technology providers. We're working on how to frame up a academic consortium membership, and that would be open to anybody. So we can get creative on different ways on how we use this information or this data to license that, or as long as we get some deliverables back in within the consortium itself. But currently we don't have anyone from academia. Everyone today is opposed from a couple of the operators. Of course, they're headquartered here. But just because we're doing, again, our first project in Oklahoma doesn't mean we're restricted to Oklahoma. We're open to globally working with anybody. And a good example is Inpex, who's a part of our consortium, and they're based out of Japan. So we're already global, and working, we'll work with anybody that is interested.
Okay. That's the last question we have here so far. We'll give another moment or two if anyone has any more questions. We'll give it sort of a last call, I guess, for questions here. And Rob, thank you so much for joining us today. It was a great presentation, and thanks to Baker Hughes for letting you come here and talk to us.
No, thank you, everyone.
And I'm not seeing any more questions, so I guess we will wrap it up. Thank you all for coming today. It was a great presentation, and we're glad to have had you here. Bye.
Thank you.